Thank you, Lindsay.
Thank you.
So, good morning, everyone. I just want to set the scene before I go into the presentation. So, in the early 1600s, Galileo looked at the night sky with the naked eye. He could see a few blurry points in the sky where Jupiter was meant to be. To the human eye, there wasn't enough data to be able to see physically what was there or happening, just a flickering point of light. So what he did, he took the first steps towards creating a telescope. He ground two lenses, he built a telescope, and he magnified the data in the sky. He could start to see Jupiter, and he found 4 moons around it. Essentially, he was amplifying an existing signal. He was making that signal much, much clearer. So that resolved into that image of a planet with 4 moons that we now know about. Fundamentally, though, the data did not change. The resolution did change. Today, many banks face exactly that same issue. When it comes to credit defaults, we're typically looking at faint, rare pieces of data, particularly in some segments, in a dark sea of data. When we try to train a model on those smaller amounts of data, it's like staring at that starry night sky, and the results are sometimes blurry and unclear. We're here today with Stuart from Aldermore to look at the story of Aldermore Bank, where we worked together as a team. We didn't just want to wait for more defaults to happen. That's probably not the best thing in the world to happen from that perspective. We wanted to get a better view of the overall data within the creation. The result of this experimentation wasn't just more data, it was a higher resolution picture of credit defaults and the risks that they potentially had. Today we're going to take you through that journey with Aldermore, where SAS worked jointly to look at synthetic data and its application within credit risk defaults, particularly when we have smaller subsets of data. And we'll show you exactly how we found that signal in the noise and amplified it.
Thanks, Paul.
So, just to introduce myself, I am Paul Jones. I head up customer advisory for financial services for SAS. I'm actually a stand-in today, so one of my colleagues, Alina Budnik, was not able to be here today. She did a lot of the work with Stuart and the team at Aldermore. And this was really, it was a collaborative effort, wasn't it? It was a real team effort between us, where we were trying to break new grounds for the bank and look at some interesting problems from that perspective. Again, as I said, I've been with SAS about 29 years. Many years ago, I was responsible for building, as I said to Stuart the other day, there's probably a credit scorecard that had my name on it 20, 25, 26 years ago when I used to actually do that type of work. These days, as I said, I head up the financial services. I'm going to hand over to Stuart now to introduce himself and take us through the initial bits of the presentation.
Thanks, Paul. I want to echo the sentiments about the work that Alina did, because Alina did a lot of the work on this, and it was a great piece of collaboration. So, my name's Stuart Jardine. I've been in financial services for about 15 years. I started off in customer-facing roles, doing telephone collections, transitioned into credit risk about 10 years ago, and that's when I started using SAS. When I was working as a senior analyst for Aldermore Bank, we did a migration from our on-premise servers to SAS Viya, and during that I was treated as a subject matter expert and worked my way up to become the platform manager for SAS Viya, which is my current role. My current responsibility is to look after the platform, make sure that we're innovating with everything that we do, we're making the most of it, and that we've got all of the tools that we need to do the things that we need to do. So you probably haven't heard of Aldermore unless you work in certain sectors of the UK, so it's a good idea that I give you a bit of a background about who we are before we tell you the story of what we did. So we're a medium-sized UK bank, operates in a number of specialist markets. So we're looking at motor, commercial real estate, asset finance, and a number of others. We're a regulated business and we require robust modelling. However, we have pockets of our business that have very low observed default rates that we can use to model on. All of that being said, we have a strong risk modelling culture that's dedicated to building models in the most robust way that we can and ensure that we manage risk the best that we can. So I'm going to tell you a bit of a story about how we came to be building synthetic data with SAS. So go back 2.5 years. Me and my boss at the time were at Innovate on Tour in London, and we listened to a presentation about an upcoming product called Synthetic Data Maker and how adding synthetic data to low default populations could build stronger models. We found it really exciting, especially given the context that I've given you about Aldermore, and we're keen to see what we could do at Aldermore with synthetic data. So Paul, at the end of this presentation, is going to talk to you a bit more about Synthetic Data Maker. But at the time, it wasn't available when we were doing this piece of work. So what you'll see is that we've done synthetic data generation within other parts of SAS. I'm going to get into some of the detail and explain how that's done later on. And if you're really interested in your technical, you can download the PDF of the slides, and in the appendix, you'll find all of the code that we used to build synthetic data, so you can go ahead and try it yourself. So, first thing we needed to do was work out who we could speak to at SAS to get things moving. So we've got a great relationship with SAS through our customer success team and our account managers, and we reached out and we arranged a meeting with Professor Ian Brown. He's the global head of AI and data science for SAS, and we set up a meeting, and it was absolutely brilliant. Ian was really enthusiastic and keen to share his time and his team's time to help us down this road. So we've now got the support of SAS, and we've got a great idea. So we need to get Aldermore's buy-in. So we went to have a meeting with the head of model development at Aldermore and said, how do we make this real? How do we convince you that adding synthetic data will work? And he said that he was very keen. He wanted to understand how it would work, and could we arrange a meeting with Ian and himself. So we had a kick-off session where we agreed what the parameters for this project were going to be and understand how we could prove the benefit of synthetic data and whether or not we could start to use it within the bank. Also, just wanted to note that we took the opportunity to give someone a development opportunity who was doing an apprenticeship and had never worked in predictive modelling before. Luke was a systems analyst. He'd never used SAS before, but he went from knowing basically no SAS code to developing our synthetic data by the end of a few weeks. So the reason I bring this up is that even if you are a fairly new SAS user, within just a couple of weeks, you could be generating your own synthetic data. So don't think of it as this big ethereal task that you need to try and figure out. So we had two hypotheses proposed by our head of model governance. Put them up on screen in this beautiful graph that we're going to keep referring back to as above-the-line experiments and below-the-line experiments. The baseline there is a set of modelling data that's fairly rich, has actually got quite a lot of observations in, and has been used for modelling within Aldermore already. Our above-the-line experiments were to see how much you could improve a model that's already built on a good sample size by adding in more observations of synthetic data. For below the line, we wanted to see how small a sample size could you use and top up with synthetic data whilst maintaining model integrity. I'm going to go into a lot more detail about exactly what we did with these. So, for our above-the-line methodology, we built a single set of data that matched exactly the number of defaults that we had in our baseline scenario. So we're essentially doubling the number of observations that we had. We ran 5 separate tests where we added in different percentages that you can see on screen back into the data and compared against the original model that we'd built with our baseline data. Now the technical bit for anyone that really wants to get their hands dirty and start doing it themselves. We started off in SAS Studio. We took our original data set and we split an out-of-time sample that was not used in any way for modelling or synthesizing data so that we could then assess back against that sample. And we separated out a development sample to build our models from. We then took our modelling data into Model Studio and we built 2 baseline models. We built a logistic regression model and an auto-generated pipeline model using SAS Model Studio's auto pipeline AI build. We then used SMOTE, so that is procas SMOTE sample for anyone in here who is a SAS coder to synthesize one block of synthetic data that contained just over 3,500 defaults, matching exactly our original population. We then replicated our model building exercise using that set of data. After we'd added X percentage back to our synthetic data, we took it exactly back into Model Studio and replicated the project that we had there and built the same logistic regression model and gave the auto-generated pipeline the same amount of time and compared the results against our original model builds. We then replicated this 5 times, adding in different amounts of defaults each time to see if we could improve the results of our model. So this is our above-the-line methodology. Below the line. So we wanted to remove some of the defaults, make the data even more imbalanced, and test the predictive power of modeling once we'd replaced those with synthetic defaults. So what we actually did was we did 99 separate tests where we removed 1%, then 2%, then 3%, all the way down until we had basically none of our original defaults left and replaced them back with synthetic data. So it starts off in very much the same way. We take our original data and we split an out-of-time sample that we can then use to test again to make sure that we don't have any overfitting or bias within our model. We then used SAS Studio to build a logistic regression model. This was different because we wanted to build a fast pipeline within SAS Studio that we could automate and we could run over and over again those 99 times. We used proc survey select within SAS Studio to reduce the default population. In this instance, 5% brings you down to just over 3,500 defaults from 3,800. And then we built another model on that reduced population, again, collecting our outcomes each time. This is when we then generated separate defaults to bring it back to exactly the same size. So you can see that our partially synthetic data is exactly the same as our original dev data in terms of the number of observations that we've got. And we finally built a logistic regression model to test again. As I said, we repeated this 99 times, this experiment, to see exactly what we could do, how low you can go with those defaults and still bring it back up. What I've talked about a few times here is SMOTE in terms of how we have generated our synthetic data, but Paul's going to explain to us exactly what SMOTE is.
So let's talk a little bit about SMOTE. So SMOTE is one of many methods available for creating synthetic data within SAS. It stands for Synthetic Minority Oversampling Technique. The method's been around about 20 years-ish. It's relatively well known in the industry. It's quite reproducible. There are a number of papers on it. So from a regulatory point of view, people are reasonably comfortable that you use this methodology from that details perspective. But how does it fundamentally work? So continuing with the same color scheme, actually, which is very matching to Innovate, where we themed it, here what we have is actually 4 defaults in a smaller set of overwhelming good loans from this perspective. So first of all, we're identifying those individual points. In this case, these are our defaults from this perspective. And then we use essentially the same methodology that you'd see in clustering, so k-means behind the scenes, to essentially, in multidimensional space, connect those individual points behind the scenes. We draw a line between those individual points and draw a mathematical connection between those individual points. The final bit is we then create the synthetic data. So notice that they are a distribution between the points. In this case, we chose a simple example with 4 points. But what we're not doing is actually replicating the individual points that already exist. Okay, so we're creating brand new synthetic data points somewhere between this. So no duplicate data, because that would cause different issues. Okay, so this is much more sophisticated than adding additional variables where you're computing means and missing values from that perspective. There are other values that you can use, things like tabular GAN, but actually we chose SMOTE, and it's interesting, the results, as you'll see, were rather interesting as we moved forward. So, what were the results like?
So I can, as I'm sure you can imagine, we were pretty excited to figure out what our results look like. And the first thing I just need to explain to anyone who's not a modeler in the room is the concept of Gini. So I'm sure most of you that have come to see something like this will understand, but for those of you that don't, it's the predictive power of a model. So our development Gini is how good our model is at predicting the development data it's built on. And the out-of-time Gini is how good it is at predicting that separate set of data that was not used in any way for our synthesizing or modeling. A perfectly predicting model has a Gini of 1, and a theoretical model that could not predict anything has a Gini of 0. So we were really excited to see what our results showed. And for above the line, we were massively disappointed. We basically saw no real benefit to using synthetic data in an already rich data set. Now, that's not to say that if we hadn't used different synthesizing techniques, or we'd prepared our data, or we were using different data, that you might not see results. But for our benefits, we didn't see results.
So yeah, so here, I think the example in your data is we had realistic, a good representative example. You'd had enough defaults to build a good model, so no added value.
Yeah, exactly that. Thankfully, below the line was a very different story. So this is where, again, just to remind you, we're testing out smaller and smaller amounts of true observations. And as you can see, as you get to the right-hand side of these graphs, we start to see some real movement. So on the screen, you can see 3 graphs: the out-of-time and development Ginis, and on the right, a performance impact graph that shows the difference between non-synthetic and synthetically enhanced data. On the right-hand side of the performance impact graph, the number of real defaults, the lower the number of real defaults, the more noticeable the impact. And once we get to around 1,000 real defaults, you can really start to see that there is something worth investigating. So that's what we did. We did some more investigation. We wanted to look at those smaller percentages where we had between 2 and 23% of our original population, so just under 1,000 defaults. And we conducted 30 tests on each one of those percentage points. So we went ahead and built another 720 models to understand exactly what we were seeing from these results and the noise.
So let's delve into those graphs a little bit more. And what you can see here on the left-hand side, first of all, when you just take a high-level reading, and again, we're retaining the same color scheme, okay? So purple is where we've added the synthetic data, blue is actually the real data only. And so if we look at the left-hand side, the first thing you pick out is synthetic data actually has overall, just even from this graph, a better Gini score. So it starts at 0.05 versus 0.4. So let's look at what we actually were plotting here. So each of those iterations, 02, 03, that was 30 experiments. So when we actually industrialized this, we were able to repeat the experiments. Now the individual dark line is essentially the mean of those 30 experiments. The darker color in between, in either blue or red there in the middle, that is one standard deviation away from the mean for those 30 experiments. And then on either side, you're looking at the outliers, okay? So that's not 95 percentiles here, to be clear, that is the full outliers within this example. Now the interesting thing is, when we overlay the 2 plots, you see 2 key things from this. Essentially, you look at the reliability score for the synthetic data. It's much more reproducible and far more stable than the actual real data. So we're getting a high confidence level and predictability with the synthetic data. And what you can also see, the synthetic data outperforms all the way in this curve from this percent until you get close to the ends to around 0.25 there, so 25% of the data. So a massive performance gain for synthetic data when we've added it, when we have small samples of the real data. So the lesson from this from us is we could pick out, in the case of this, that we could actually see between 4 and 23%, so a small number of defaults, synthetic data added a massive amount, right? And that's really interesting, because if you're a bank, or a finance company and you're entering new markets, new segments, maybe you're entering, I don't know, buy-to-lets or other segments where you've got different characteristics, we're seeing tremendous power through synthetic data to make accurate predictions. Equally, if we move that into other cases, fraud within banks, where we're seeing new emerging threat types, what we're learning from these lessons with synthetic data is that we can accurately apply it on new cases and make conclusions that can tremendously improve the model predictability power. So if you're able to, for example, in fraud, reduce an attack pattern earlier on, that's very interesting because you can have a smaller sample but still make accurate predictions and close off those fraudulent cases. So we think within banks, there is tremendous potential to introduce synthetic data into a lot of day-to-day operations, and that's the high-level conclusions from this slide. But we wanted to take it a little bit further, right? We wanted to ensure our synthetic data is reliable and a proper statistical twin to the original data set. So we wanted to do some more comprehensive, what we called data fidelity and utility audits from this case. So first of all, on the left-hand side, we wanted to concentrate on what we call statistical similarity, okay? So we use metrics like the Jensen-Sanderson divergence to look at the distance and the proportions in the categories are realistic. And we calculated numerical statistics, things like means, standard deviations, to essentially see that the distributions and the data overall looked satisfying. So we were reproducing data that was realistic and statistically looked okay. On the right-hand side, we looked at relational similarity. We used techniques like the Spearman correlation, that's been along a long time, for looking at those individual variables. For numerical variables, as we said, we wanted to show that we were actually remaining linked to the synthetic data, that it actually had the correct rank orders within the framework. And so we wanted to combine these two together, really to an overall similarity score. The next page really actually shows us plotting the graph of that similarity. So again, 720 experiments. Remember, each of these points, 2, 3, is 30 individual experiments overall. So this represents how good is our synthetic data to represent our starting data in this case. And so the similarity score, okay, is the line that we see in there, and the color of the circles here, okay, is the statistical similarity score. Darker is better in this case, and the size is the relative similarity score for that. So bigger is better. So if you see, for example, just above 2, then that's a smaller circle, so we get a lower score there. What is incredible, that even with that small 2% of defaults here of real data, we're still getting between 0.94 and 0.84. So 10% off from the real data, right? And then if you move along here, so it's ultra stable, right? It really does represent the data. So we really get, again, pleased with this. And this experiment really proved out, A, its predictive power, and B, that it really did represent the data. So Stuart, what did you do with all this data once we found this out?
Thanks, Paul. So from our point of view, and with our data, where we've already got a significant number of observations, we weren't seeing the benefit from SMOTE. Again, that might be very different for you, and it's worth you doing your own experiments. But what it meant for us was that data with low levels of observations can be enhanced with synthetic data, and we can make better models. We can produce models with a higher predictive power, which is great, but also one thing that we weren't expecting is that those models are more reliable. We can more reliably produce good models. So it's definitely led us to believe that there's going to be gains for us in using these techniques in modeling. Addition of synthetic data is giving us a slight uplift in model performance, but greater consistency and greater confidence in the models that we're building. Going all the way back to the beginning where I explained who Aldermore is and what we do have lots of smaller portfolios that have very low default volumes, and using these methods can produce much more consistent models. So we've evidenced these reliable and predictive models, and we presented it back to the head of model development, and he is now moving forward with actually going to start using synthetic data in our next model build cycle. So we recommended that anything where you've got observations between 154 and 886, which is an event rate of 0.3 to 1.6, that they start using synthetic data. and they've taken that on board, and that's their plan for this next model development cycle. We're actually going to be using synthetic data. So who knows, maybe I'll be back next year telling you about all of our brand new models that we've built. But on those points, the average Gini of the real data was more than one standard deviation lower than the average Gini where synthetics were added. So at Aldermore, we were keen to see how we could build better models where we lacked real observed defaults, but we specifically chose to look at and predicting defaults within financial services. But what we were actually doing was we were proving that a model with real low observations can be improved by adding synthetic data. The process is actually completely agnostic when it comes to subject matter, and it could well benefit any type of modelling industry where you've got rare cases or sparse observed data. Not only did we show that we can improve the predictive power of the model, but we showed that the models that we're making are highly likely to be more reliable.
Okay, thanks, Stuart. So if we look at what we talked about today, synthetic data doesn't exist within isolation of what we would call the classical analytical lifecycle. You've probably seen this diagram multiple times from SAS in the conference and when you've been talked to us. But in a real production environment, synthetic data, as we said, it's not in isolation. It fits into this lifecycle. And so in phase one, really what we're trying to do is within this, and this is what Stuart did. He used SAS Studio to do the basics that you want to do, industrializing the process, right? You want standard ETL and routines to productionize this. So first of all, what we need to actually do in phase one is split and stratify that data, create essentially a holdout sample in the case of this, and put the real data into test and validation, call them vaults or something like that from that. Then, in this case, we used the actual method of SMOTE and actually synthesized that training portion to then build the model. And what we also want, and that's one of the key things, and I guess a lesson from this, is actually having those predictions, and the industrialization allows you really to check that synthetic data for basically utility. And that's what you saw in the plots I was presenting, is we did that due diligence around it. You can't just use it without actually having those control frameworks around it. And that was really important within this. Phase two is developing the models from that, building the credit risk models. You know, we used classical logistic regression, the most common methodology that we would see within credit scorecard development, where you add things like weights of evidence and so forth to build the model in those cases. And that's where we use the real and synthetic data particularly with those minority patterns when we did that simulation. In the case of that, we did the benchmarking, did validation. So this is about building a framework out, right? And in the case of Aldermore, what they actually did that framework with using technologies like SAS Studio and code in this case. And then phase three was then that deployment of the model, which is, I guess, the next stage of the journey for you that they're planning for later this year. Now, the final thing I wanted to mention is talk a little bit about Data Maker. So again, in this POC, where we're working with the customer, we started this before Data Maker was generally available as a technology. And so Data Maker actually gives us a number of capabilities that are available more widely, and it's built, first of all, with a very friendly graphical user interface. So you don't need to learn coding. It's a low-code node environment. It is available, software as a service. So in fact, if you wanted to, literally after this, you could sort of put your credit card in, go onto the Microsoft Marketplace and have a little play. And it's based on a metric of how much data you're creating. So relatively easy to start quickly and lightly from that perspective. But actually it has a whole set of additional capabilities. So first of all, it has numerous diagnostic capabilities. So straight out of the box, when it creates the synthetic data, it will actually give you all the graphs showing how closely it matches and all that. So none of the framework buildings that we talked about earlier, all of that is out of the box for various different methodologies, and it actually gives you that information straight away. But Data Maker does also quite a few additional things. So it includes automatically checks for bias, but it also has things like privacy filters. And it also creates synthetic data for things like names, addresses, and so forth. So not just the numerical stuff that we were talking about here. It's a much wider tool from that perspective. One of the other clever features is it also includes the ability to create data for linked data sets. So when you have integrity constraints, so imagine you had a customer table, an account table, a marketing table, and they're all joined with strong relationships where the variables match. Well, Data Maker will automatically honor those connections and create a complete synthetic data copy of that data and include all those indexes and matches automatically just with a press of a button. And it also includes another feature called differential privacy. And that's where it will obscure the data. So one of the key capabilities is to be able to actually create a data set that looks like your original one, ensure that there is a privacy filter so that you could share it potentially with external agencies. So for example, in something like pharmaceuticals, and you had patient data, you could also use this product to essentially create an anonymous copy of it. We're seeing use in government for the same thing, where they want to share data about citizens, but they don't want to share the details of the specific data. And these privacy protections and anonymization, but sound statistical representation of the data are fundamentally built up and built in Data Maker from the ground up. So it's a very interesting technology from that perspective. I would encourage you to go to the demo stands and to have a look at it. And just to close with, there are two further presentations around synthetic data at Innovate. One of those is today from Catherine. You can see that this afternoon, looking at specifically how Data Maker works and how you can use the technology to drive change quickly. And Priscilla will be presenting on governing synthetic data revolution around the trustworthy and the protection aspects that I talked about. And that is a presentation early tomorrow morning. So have a quiet night of the Texas evening tonight if you want to attend that one from that perspective. That's it from us for now, but we're absolutely open to any questions.
Yeah. The only other thing that I'd add is just a reminder that if you're interested in looking through the slides or any of the code that we used or the process flows that we used in Model Studio, they are all in the PDF that you can find through the app or on the website as well. And if you don't get a chance to ask a question or if something comes up later, reach out to me on LinkedIn or send me an email or whatever you want to do.
Yeah. And again, your SAS teams locally that work with you, they absolutely will be engaged with synthetic data. It is one of our high priorities this year to work with our customers on that. So if you have questions, again, your local team, I'm sure, will be really happy to support. But it's a great opportunity while you're here to ask anything. Any questions from anyone?
Yeah, so if you guys want to raise your hand if you've got a question and I'll come running, we've got time for a few.
We've got one down there.
Stuart.
It should just be coming up.
Hey Stuart, really good presentation and thanks Paul, that's really interesting.
Thank you.
The way, if I understand correctly, that the synthetic data was generated was basically using K means like
SMOTE.
nearest neighbor.
Yeah, that's,
and then
yeah,
basically
yeah.
you basically generate
Yeah.
synthetic data in that region,
Yeah,
right?
correct.
So what, like on what factors or like what data fields are you using to do the clustering in the first place, and then essentially, it's kind of like, in my mind, is it a sort of self-fulfilling prophecy? Because essentially I'm generating the synthetic data on certain data attributes, right? And then when I run the model, the performance will be better. Am I missing a point?
No, so I 100% agree that I'm not a data scientist by trade, and that was one of my initial questions, one of my concerns as well. The methodology around SMOTE and the way that it fills in those gaps means that you don't have exactly the same defaults. So you have similar data, but it's not identical. But we were able to prove that it was relationally similar as well as statistically similar without being exactly the same. And then obviously our testing was always against an out-of-time sample that had not been used in any way for the synthesizing or the modeling. So
to your point, it's on all the variables though. So if you had a credit scorecard with a binary outcome, it generates it for every single variable.
yeah.
Yeah.
Yeah, and then the performance metrics that you showed on the screen, particularly on the synthetic data, was very sort of promising,
Yeah.
almost exciting
Yeah.
from a nerd.
It's not the first time we've done it with banks. So I think Stuart was enthusiastic because we literally did a project, was it a year before that you attended, where we showed equal stroke better results with a bank,
Yeah.
another organization on a mortgage portfolio. Yeah.
So just so I understand correctly, the out-of-time sample is actual real data.
Yes.
So
It's a holdout sample.
performance is
Yeah,
using
independent.
the model that was built with synthetic
Yeah.
data.
Yeah.
Exactly.
Yeah. Exactly.
Very impressive.
It's a complete holdout sample.
And do you see different performances of the synthetic data sort of approach? Like for example, some portfolios, the default might be more sporadic, so there's less sort of similarity between defaults. When they're sort of overload level, does the synthetic data?
So our point is, on all these methodologies, you need to do due diligence. You can't just press a magic button and it works. So you need to understand, you still need statisticians. So we still will have a career. I think we're now called, data scientists these days. I'm old, so I used to be called a statistician. But yeah, you will still need them. You still need to understand the methodology. And you still need to do the due diligence. That's the point. Both Data Maker and the approach we had with Aldermore had a set of due diligence checks. It's not just press a button and go. But it's not hard. So the whole project was how long end to end?
So once we actually
Everything.
we got going, we had a couple of false starts where other priorities took over, but end to end, I think we're 6 weeks.
6 weeks and all that, right? So it's pretty fast if you sort of put your mind to it.
Well, I think if you're a SAS coder and you want to have a go at this, the code's about that. It's like a paragraph to do it in prop CAS, and it's in the slides. So have a go, have a play with it, and if you get stuck, give me a shout, and I will pass you on to Alina because she's much cleverer than I am, which is why I wish she was here.
Yeah.
Yeah, so my question is, what was the reason the above-the-line approach, where we are adding more synthetic data for the underrepresented class, did not work, while the below-the-line worked? What was the reason behind that?
I'm going to be completely honest with you, we didn't spend as much time digging into that, just because we had other priorities to work on. We've got other theories about things that we can look at now in terms of different data preparation, data selection, variable selection. There are things that we can experiment with, and potentially using things like GANs as a different method of synthetic data generation. But yeah, complete honesty, we don't know. We didn't spend as much time looking into it because we saw the results on the below the line, and that's really where we wanted to get the gains anyway.
Yeah, I mean, there's enough, you had a reasonably good model before
We did.
in this area. So the question was, do you spend time there, or do you want to concentrate on a portfolio where you have a set of rare events and then see whether that performs? So it was a business decision, really, that drove it from that perspective.
Yep.
But we do see in other portfolios, to be clear, we have seen additions of synthetic data having improvements. But the use case where we see the most value is in those rarer event occasions, okay? So small portfolios where defaults are starting, or dramatic changes, for example, in economic circumstances. Those situations where things change massively, then that default profile in your models are going to change over time and your genies will go down. So you need to look at those scenarios. It's not there isn't, as I said before, no magic answer. You need to do due diligence around the frameworks.
Hi, thanks for the presentation. I have a quick question. You might have already explained, but so when you generated the synthetic data and then compare the accuracy on the out-of-sample testing data set, in the process of generating, did you use that held out data?
No.
Okay.
No, not at all. No, that was completely separate.
Okay.
So if you jump back into the PDF, if you get a chance, in the diagram, you can see that we completely separated it out, wasn't involved in the synthesizing at all.
Okay, thank you.
Nice.
Any more questions?
One at the front.
Oh.
I think we'll bring the mic up for you.
Hold on.
Please.
Yes, thank you for the presentation. Very interesting, and it's not applicable not just for banking, but everywhere where we deal with rare events like churn and so forth. I was wondering if you try to evaluate other than Gini metrics, your methodology. So did you try, say, I don't know, F1, lift, other things?
So this is another moment I wish Alina was standing here next to me. She is the data scientist, and she absolutely did look at those statistics. They didn't mean much to me because I'm not a data scientist by trade. But our bank worked primarily in Gini, and so that's how we had to present the results back to them. But Alina tells me that the rest of the results did kind of stand up outside of Genie as well, and I'm sure that if you wanted to reach out, I could get her to share some of those results.
Sure.
Yeah, it was a full set of diagnostics.
Sure.
Yeah.
Thank you. I just didn't see it here. So the other question is how the regulator is thinking or approaching the methods based on the synthetic data in the UK?
Yeah, so it's interesting. The regulators in the UK are very much aware of it, and they're very much interested in how it's going to work, but they're actually supportive at the moment. It's on our kind of roadmap to start having those conversations about us using it specifically, but they have reached out to us and they have been running sessions around using synthetic data within the UK market themselves. So we believe that it's something that they're keen to, they will be supportive of.
So the one thing I'd add is you've got, say, Tabular GAN, that uses neural networks. Pretty hard to explain as an example. SMOTE, pretty well-known methodology. Published papers for the last 20 years on the methodology. I just covered high-level SMOTE. There's actually some nuances to SMOTE. There are like some sub-methods below it, but it's a very well-known published statistical method. And so what we've seen with the PRA when we're working on modeling types, for example, which is the regulatory authority in the UK. So when we look within, I guess, that domain, they want to know that the methodology's been out for a while. They want to know it's got credentials and so forth. So I think one of the reasons to choose SMOTE is that clarity and acceptance within the, hopefully within the industry around those things. So other methodologies may have statistical advantages in producing better data, but you won't have the auditability, the control factors, and other things that you might need for visibility. That's why logistic regression is still used primarily in credit scorecards, and people have not moved to some of the newer methods, for example, because they can't be explained so easily.
Of course, the methods based on k-means are also suffer from outliers, etc. Everything that affects the Euclidean metrics, so it would be questionable, but I leave it to to the practice. Thank you.
Thank you.
So thank you so much, and I'd love if you guys could show your appreciation for Stuart and for
Paul.
Yes, thank you.
And thank you for coming along.